Imagine a software developer who never sleeps, never takes a coffee break, and writes flawless code in milliseconds. You might think this is pure science fiction. It is not. Right now, autonomous AI software engineers are rapidly deploying into the real world. We are moving far beyond simple code completion tools like GitHub Copilot. Current paradigm shift involves fully autonomous coding agents. These intelligent systems can plan complex software architecture, write thousands of lines of code, test specific modules, and deploy entirely functional applications. Look closely at systems like Devin, developed by Cognition Labs. Devin does not simply autocomplete your function. It actively creates its own isolated sandbox computing environment. It browses external API documentation independently when it encounters an unknown software library. It actively debugs its own logical errors in real time by reading the terminal output. If a test suite fails, the agent rewrites the logic without any human intervention. This represents a massive structural shift in how software will be built over the next decade. The fundamental unit of software creation is no longer the human programmer typing manually on a mechanical keyboard. The new fundamental unit is the human product manager orchestrating a vast synthetic workforce of specialized AI coders. Multiple Silicon Valley startups are already replacing entire back-end engineering teams with these autonomous systems. This hardware and software revolution is happening right now, and the speed of daily integration is accelerating exponentially. How do these synthetic engineers work under the hood? The secret lies in a core concept: agentic reasoning loop. Traditional language models operate in a strictly linear fashion. They read your text prompt and spit out a single static response. Autonomous agents operate in continuous, recursive decision cycles. They utilize a robust framework as REACT, which stands for Reason and Act. When given a complex coding task, the agent first generates a sequential, step-by-step architectural plan. It then executes the first step by interacting with a real command line interface. Carefully observes the specific output from the live terminal. Based on that exact digital output, the agent updates its internal context and decides the next structural move. If a Python script throws a syntax error, the agent actively reads the traceback log. It understands exactly why the specific code failed. It then independently modifies the relevant file and runs the script again. This continuous feedback loop allows the AI to navigate highly unpredictable coding environments. These intelligent systems are powered by massive foundation models like GPT-4, Claude 3, and proprietary enterprise architectures. They are heavily equipped with expanded long-term memory solutions. This critical upgrade allows them to remember previous architectural decisions across thousands of complex files. They can now maintain entire legacy codebases without losing vital context. This is not just basic text pattern matching anymore. This is applied, systematic problem-solving executed at an incredible machine scale. What does this mean for the global software industry right now? The economic implications are massive, unavoidable, and immediate. Consider the typical software development lifecycle in a modern enterprise company. A basic feature request usually takes several weeks to process through various human departments. It requires product managers, senior systems architects, junior developers, and quality assurance testers. A fully autonomous AI agent compresses this entire timeline into mere minutes. Potent open-source models like Princeton's SWE-agent can resolve real GitHub issues entirely automatically. They download the target repository, isolate the stubborn bug, write the precise patch, and submit a polished pull request. In recent rigorous testing benchmarks, these AI systems successfully resolved nearly 25% of complex, unseen back-end issues. This dramatically lowers the heavy barrier to entry for global software creation. You no longer need a massive engineering budget to test a new software product. A solo entrepreneur can now leverage a relentless army of synthetic developers. They can deploy complex, properly scaled server infrastructure overnight. Major tech giants are currently aggressively integrating these agents into their core proprietary workflows. Microsoft, Google, and Amazon are all rapidly building extensive internal synthetic workforces. The ultimate financial goal here is hyper-efficiency. Companies want to build significantly better, faster products without continuously scaling their expensive human payrolls. Does this mean human coders are completely obsolete? Not entirely, but their daily workflow is about to change drastically. We are swiftly transitioning from an era of manual code writing to an era of AI code reviewing. Tomorrow's successful developers will act much more like technical product managers. They will spend their valuable time defining high-level system architecture and writing highly precise prompts. The tedious grunt work of writing generic boilerplate code and squashing minor syntax bugs will be entirely outsourced to the machine. This massive shift requires a completely different cognitive skill set from the modern tech workforce. Being a dedicated master of syntax in a specific programming language will no longer guarantee you a high-paying Silicon Valley job. The new premium will be heavily placed on abstract problem-solving and deep systems thinking. You desperately need to understand how different complex APIs connect and how to securely structure massive cloud infrastructure. You also need the sharp ability to critically review AI-generated code for hidden security vulnerabilities. A synthetic engineer can easily write 1,000 lines of functional code in seconds. However, it currently still lacks the human intuition needed to understand complex business logic and nuanced edge cases. The smart developers who survive this industry transition will be those who actively learn to leverage these agents as powerful force multipliers. They will ruthlessly use AI to increase their individual creative output tenfold. The actual timeline for this unprecedented technological disruption is shrinking rapidly. We are not talking about a distant speculative future decades from now. The first generation of highly viable autonomous AI engineers is already actively deploying in live production environments today. By the end of this current calendar year, we will likely see hyper-specialized intelligent agents dominating specific enterprise niches. We will see autonomous AI database administrators optimizing complex server queries entirely on their own. We will see synthetic AI front-end designers converting simple UI/UI wireframes into massive responsive React codebases in mere seconds. The historical technical barrier to building highly scalable software is effectively approaching absolute zero. The only real competitive limitation remaining is human imagination and relentless strategic execution. Are you truly prepared for this massive structural shift in the global tech ecosystem? Do you currently possess the abstract systems thinking skills required to successfully manage a synthetic workforce? If you desperately want to stay ahead of the curve and navigate this coming digital transformation, you need highly actionable intelligence. That is exactly what we specifically provide here at NeonSync AI. Hit that subscribe button right now and aggressively turn on notifications. We slice through the meaningless hype to bring you the critical signal. The future of global technology belongs exclusively to those who actively build it. Let's build it together, 1 minute at a time. Stay sharp out there, and we will catch you in the next rapid.